imagine you have an essential state. So I is essential, and I leads to a state K. Okay. Then K is also essential. Right. It's like, what do you have in this page rank algorithm? I mean, if you determine, or if you know that some website is important, so if an important website is referring towards another website, so it's going to be important as well. Anyway, so we'll get into it. Because for Google actually, these all websites are like the states. Anyways, we'll get into the page rank algorithm. So how can I show it? Do I need to show it, or you can do it for yourself? So help me out. How should I run the proof? So if I is essential, what does it mean? If I is essential and I is referring to K, by definition, K is also going to refer to I. Okay? So in other words, I and K must be intercommunicating. But how does it going to show that K is essential? Okay, so you have to think about essentiality of K. So how can you show that K is essential? So here's the thing. So since I is essential, and it's given that I is leading to K, then definition tells me that K leads to I as well. K and I are intercommunicating class, but my claim is that K is essential as well. So in order to show K essential, what should I show? So I need to take an abstract J to which K is connected. And what we would like to say is that in return J is also connected to it. So can you think about it? So let K leads to J. So how can I show that J leads back to K?
J leads to I and then I leads to
J doesn't leads to I don't know.
Sir, can you say that I plays a role of J here?
No, I mean I is particular, J is abstract actually. Okay, so I know about that K leads to I. Any cases. So I can say this. Here's the thing. So I know that I leads to J and J leads to K. Okay? You can have it. Okay? We have it this. So what would be the relation? No, sorry. I leads to K and K leads to J. So what would be the relationship between I and J?
I leads to J.
Can I say I leads to J?
Yes.
But I is essential.
So
J leads to I.
And I leads to K.
So done. Take care. You are done. Okay? So essentiality, so I can write this as that essentiality is being essential is a class property. So being essential is the class property. So what do I mean by class property? So it's a property that would be, so if any one of state in a class has this essential property, okay, being essential property, then the entire class has that property. ठीक है जी? So So if the different states are connected to different states, and we can see that if I start from, for example, the previous example that we had, so if I start from state 2, I can make a round and I can return to 2 actually. Okay. The question is, you can always ask the question, this question about a state that, okay, if you are leaving one state, are you going to return back to that state or not? The answer can be yes and no. So if the answer is yes, you can ask the next question that, okay, after how much steps actually? How much expected number of steps you're going to return to, what is it called, the same class again. Okay. And returning to the same class, you can think of it as roughly periodicity. It's like a being periodic. So the next thing that I would like to define is, periodicity. So quick definition is that the period of the state is the GCD. Okay, so it's the greatest common divisor of times at which chain might return to state at. Return to state. Okay. Thus, we will say I returns to I, or I leads to I, after going through other states, or maybe not going other states. It's not necessary that always a state. So state can return to itself, and you can have the situation as well. So if you have this, then the period of I is going to be precisely what? Period of I is the GCD. Okay, so the greatest common divisor of all those numbers, positive numbers, such that the probability that you start from I and you return back to I in n step is positive. Okay. Is it making sense? So I returns to I. So if this happens, then what will be the period of such kind of a state? The GCD of all those n for which the PII is positive. In other words, you have chain. We'll do an example. You have a chain in which you are returning in the first instance, for example, and then you are going through different states, and then you are returning. Okay, so you can have different numbers actually. So I returned in one step, and then I have a link for which I would say that I return back, but in 4th step, then I have another link actually through which I am returning in 3 step. So what should be the period of this step actually? So take the GCD of all these numbers. if I is not leading to I, okay, then what are you going to say? I has no period. I'm going to say I has no period actually. Okay. And the third thing I can define precisely as that if I has period 1, okay, what would be the meaning of
Prime something like it. मतलब जाएगा एक तरफ.
no, you
मतलब तीन
just
तरफ
took
जा
the
रहा है.
GCD, you took the GCD
Yes,
of
sir.
different and turns out to be 1 actually.
One, right.
Okay. Then you're going to say that it's a periodic actually. Then I is a periodic, okay? So what was the previous example? Let me quickly draw it again. So I have this 1, 2, 3, 4.
Sir,
J, J.
is there any difference between has no period and period 0?
Period 0. You need to define it. And if you want to define,
In case of feather, I tends to I. In one step we can say.
but if it returns to, okay, it returns to I in 1 step, but it also returns to I in how many steps as well. So you can have
Steps.
2 steps. It can also return in 3 steps as well. Okay, so going one way, going to the other state, and then returning back actually. So what would be the GCD of all these numbers?
One.
So you're going to have 1. So you're going to say it's in a periodic state. It's in a periodic state. So I mean, you can apply definition. Okay, and you can think of. I hope the change is fine now. Okay, so what should be the period of this state? State 1 actually. Can we think about the period of state 1? So 2, 1 होगा, so should be 1.
So एक तरफ से 5 हो रहा है, एक तरफ से 1 हो रहा है.
So should be 1. Okay, so 1 is a periodic actually. Okay, and we can prove actually, okay, that the periodicity is a class property. So if 1 has period 1, then all classes has period 1. How about 5 and 6? Well, keep in view the definition as well. Don't just jump to the conclusions. 5 and 6. Start both at period 2. Because you start from 5 and want to return 5, you have to take 2 steps. You start from 6 and you want to return to 6, you have to do steps. There's no other way. Okay, so 5 and 6 has period 2. If 5 has period 2, so that's a class, so the 6 also has a period 2. Right? It's not difficult to judge the definition. Maybe an exercise could be to think that periodicity is class 1. you think of why? How are you going to shoot? How are you going to start the proof actually? It's a class property. How are you going to start the proof?
First we need to show that one has a separate
नहीं,
class.
इसके लिए नहीं करना. This is a general basically. You take any Markov chain which contains class, okay, should have the same period. So you're gonna start. Let's take two communicating classes. So if there are two states which are communicating with each other, so they must be in the same communicating class, right? And let's assume that this I has a period D. Okay? So your task would be to think of showing that J also has a period D. Okay? You know the definition, you know the Chapman-Kolmogorov equation. So the hint is really to show the Chapman-Kolmogorov equation. Okay. So see, we are talking about different properties of chains and classifying the classification of the states. I'll finish today's discussion with an example and a definition. One of the interesting things that you can observe while talking about, for example, classification of the states, nowhere we have used, a transition matrix actually. So we haven't talked about the probabilities. Okay? So in other words, these were the properties that, you can know about the chain without even looking at the probabilities actually. Now, can we classify, can we know about the states of the, basically chain even more if we start using what we call transitions? Or can we classify them more? The answer is yes. Okay. Go to the definition and then talk about it. So for two states in S, by distribution of Pij, which I'm going to tell you in a minute, I can tell you now. The first passage time from state I to state J. Okay? Take two states and Tij is denoting what? The first passage time from stage I to stage J. I'm going to define in a moment that what do we mean by first passage time. That's roughly what is the minimum time that you need to, reach from I to J. So you can reach from I to J in many different ways. So I can reach from 1 to 3 in this chain in many different ways. Okay? But what is the direct way, or maybe it's the shortest way to do that. Okay. State J, and I'm talking about the distribution of this. Obviously, it's going to be a random quantity. Wouldn't that be a random quantity? Certainly going to be a random quantity. Okay. So if it is a random quantity, we can talk about its distribution. Is defined by, so its distribution is defined by this one. So the probability you are at I in the beginning, and the time that you need to reach from I to j is n. Okay? Is equal to a long expression, but I'm giving that long expression a name I to j n. You can you see that this is a good symbol actually? So it's the first time to reach from I to j, and we are assuming it to be n. So it makes sense to call it Fnij, but this has a meaning where this is important actually, that we must realize that why the notation the way it is actually. Okay? So it's not just out of the blue, it has a meaning always. So this means probability. So how can I say that I reached to state j on nth attempt actually, not before it. So this should be what probability that I started from I, okay, and at time 1
It is not J.
I am wherever, but it's not j.
Yes, sir.
At time 2
It's not
I
J.
can be anywhere, but it can't be j, and so on and so forth. On the nth step
It's
I reach to the j. Can you see this?
Yes, sir.
So if you wish, you can write it that xk is not j for k equal to 1, 2, and up to n minus 1. So in each of these times you haven't visited what we call it. Okay? So this is the definition of Fnj. Okay? Another very clever notation. So I want to go from I to j. The answer, the question. Can I always go from I to j? Not necessarily. I mean, you can go as well, okay? But it's also possible that you never go. So if you can reach from I to j, in how many steps I can reach there?
For example,
In 1, maybe in 2, maybe in 3. So by f is star ij, I mean the probability of reaching from the state I to the state j. So this probability, if I have to write it in the terms of these guys, how should I write? Maybe I reach from I to j in the one step.
yes, sir.
If not, I can reach from I to j in 2 steps, okay, and so on and so forth. So I can write the probability for reaching from I to j, eventually is basically this series. Fi j k, where k runs from 1 to infinity. Okay?
Yes, sir.
K runs from 1 to infinity. So see, one thing that this event can be written as the union of these events actually. So therefore, and fifth be the probability measure, so therefore the probability of the union becomes the sum actually. You have a sum which has a meaning behind it. Is it making sense?
Yes, sir.
Okay. What would be, okay, just a careful bit of notation. So it should be, the first thing when I was learning all this stuff was absorbing the notation actually. And I struggled a lot when I was basically, learning it. Because I had no idea what the heck is going on. So what I want to show is that, okay, you should absorb the notation. Okay, you shouldn't be stuck with it because then you can write things easily in the terms of it. Okay. What should be the probability that you're gonna reach from I to j, maybe not even in Qayamat actually. So what do you think, what should be the probability of happening this? Any guesses?
So that is depending on I and j, the states.
But can I have a relationship between?
1 minus that.
So what does this mean? This means you will eventually hit I, you will reach from I to j. And what does this mean? You will never reach from I to j. So it should be 1 minus f star ij. Okay?
Yes, sir.
1 minus f star ij. We'll find a definition. Give a state name that has this property. So imagine a state for which you have it. So what name you would like to give such a state actually?
Essential.
Yes, actually.
Reachable, kind of reachable.
Reachable. Reachable. What do you mean by reachable?
Intercommunicating.
Communicating.
I can reach to j, or I can lead to j.
This is I, not J.
I.
Okay? So it's I.
Trivial, sir. Trivial, sir.
No, that's not trivial, not necessarily trivial. I goes to I. So what name should I give such a state a name?
Self-communicating.
Uh-huh.
Self-communicating.
Self-communicating could be a good name. Okay? But, though that person who introduced this first time, he called, then I is recurrent actually. Okay? It's a recurrent state. So it's a state which can come back to itself. Right. What if this happens? It's not one. With one probability, what does this mean? With 100% probability, you're going to return to I. You're going to return to I. Okay. Mean